All right, so we're doing the Desmos activity on polynomials. Right now we're going to start with this polynomial. It's in standard form, ax squared plus bx plus c. We notice that the exponent is 2. So from our ed puzzle, we know this has a degree of 2. We mess around with this. We want to play with the sliders here to see how many zeros we can make, how many max mins we can make. And little side note here, a cannot be 0. All right, because if a is 0, it's no longer a degree of 2, okay, because that whole term is gone. All right, so a cannot be 0. All right, so right now if we mess around again and bigger we make a, right, the skinnier the graph goes, right? If a becomes negative, it's going to flip it upside down, same as we've always determined, but now we're going to really pay attention to end behaviors based on the degree and the leading coefficient. I move b around. Okay, so I get right now I have no x-intercepts. Okay, now I have one x-intercept. Now I have two x-intercepts. Right, I could do that same thing with c, one x-intercept. Right, no x-intercepts, two x-intercepts. Right, turns, it's always got one turn, no matter what I do to a. Right, it could flip, but it's still just one turn. All right, so how many x-intercepts could you make? So I was able to make 0. I'll show you that again real fast. What 0 look like? 0 looks like that. All right, I was able to make 1. Okay, there you go. And I was able to make 2. All right, you cannot have more than 2. It's a parabola, right? So one turn, okay, there's only 2 things going up and down forever, so that's it. Okay, how many extrema? So with the parabola, there's always one vertex, okay, always. Right? You can't make it a straight line, then it wouldn't be a quadratic anymore, and you can't have more than one turn. So that's it. All right, so same question, but now we're talking about a third degree polynomial. Exponent, highest exponent is 3. Okay, so we're looking at it right now. I see that there's 1, 2 x-intercepts. There's 2 turns. What if I just lower this a little bit? Now I have 1, 2, 3 x-intercepts. All right. It makes it a little bit bigger. Now, I have 2 turns. Now I have no turns. Okay, and I have 1 x-intercept. All right, let's put it back. So we have 2 turns again, 3 x-intercepts. Okay, the left side's going down, the right side's going up. But if I make a negative, now the left side's going up and the right side's going down. Right, a is negative, the right side's going down. Okay, there's 3 turns, 3 x-intercepts. I raise it up, I could raise it up. Okay, and see, all right, that I could get 1, I could get 2 x-intercepts, I could get 3 x-intercepts, but there's no way for me to get 0 x-intercepts because the range is all real numbers. The left side's going up forever, the right side's going down forever. All right, and so it's all real numbers. It's got, and if I flip a, make a positive, now the left side's going down forever, the right side's going up forever. It's always going to go through the x-intercept at least once, right? Twice could happen and 3 times could happen, but never more than that. So that, take a look. How many x-intercepts? Okay, could I make 0? That was impossible. It has to have at least 1 because of the range being all real numbers. All right, I can make it have 2 if one of the turns hits it and one of the endpoints, and then 3 was the most. Okay, again, the exponent was 3, 3 was the most. Okay, how many turns? Okay, so with the turns, you did see that I was able to make it, right? I have 2 turns here, but I was able to make it so that there are no turns. There's no way to get 1 turn because if it had just had a 1 turn, then the end behaviors would be going the same direction. So I'm either going to have no turns, as you see here, or I could have 2 turns. So no turns or 2 turns. Okay, now I'm talking about a 4th degree polynomial, okay, which is an even polynomial. We're looking at our m behaviors. They're both going up. If I make a negative, now they're both going down. Okay, so A is controlling, all right, the direction. So I have 1, 2, 3, 4 x-intercepts right now, 3 turns. Again, I could manipulate this. So now I have, right, 1, 2, 3 x-intercepts. Is it possible to just get 2 x-intercepts? Here I have 3. Here I have 1. If I could get it there. Close enough. And then if I wanted just 2 x-intercepts, so I could get no x-intercepts, right? I could get 2 x-intercepts. All right. I could get 1 x-intercept. All right. I could get 3 x-intercepts. So there's a lot. I could get 0 through 4. All right. Turns. I got 1, 2, 3 turns. Can I manipulate this into anything else? Still have 3 turns, still have 3 turns, and now I have 1 turn. 1 turn. Okay, can I make it have no turns? Nope, because that would mess with my end behaviors. Can I make it have 3 turns? Yes, where can I get? There's 3 turns, but can I make it have 2 turns? 2 turns will not work. Okay, because again, if I had 2 turns, my end behaviors would be going opposite. I have to have an odd number of turns. Okay, 1, 2, 3, odd number of turns and keep my end behaviors the same. All right, so we should be able to answer this question here. Again, how many x-intercepts? I can make 0, right? I can make 1, I can make 2, I can make 3, okay, and the most, I got 4 on there twice, so I've got to fix that for you guys. And I could have 4. Okay, how many extrema? Again, so since my end behaviors are the same, I have to have an odd number of extrema. I could have 1 turn, okay, or 3 turns, and that's it. All right, so this one is an important one here. Kind of puts everything together. So I got 3 different graphs on there. I got an orange graph, I got a purple graph, and I got a black graph. I want to know if I could just look at the graph and determine, what is the degree of that graph. All right, and so to do that, we want to look. So let's focus on the orange graph first. Okay, how many x-intercepts does that have? It has 1, 2, 3, 4, 5 x-intercepts. Okay, and so based on our findings, right, the most it could have, it matches the degree. All right, so, but the degree could be higher, as we noticed, because when it was a 4th degree, we could make it have 0, but we couldn't have it make it have more than 4. All right, and then the turns, okay, are going to play an important role. How many turns does it have? 1, 2, 3, 4 turns. Okay, and behaviors are going in opposite directions. Okay, so this is an odd degree. Again, the most is 5. Okay, so this is going to be a 5th degree. So the orange is a 5th degree. Right, number of turns is 1 less, okay, than the degree. Again, I can make it have fewer, so the minimum degree is 5, but we're going to learn this is actually a 5th degree function, okay, based on that there's nothing going on, there's no turns outside of that or no points of inflection going through the x-intercept or anything like that. All right, so now let's focus on the purple. The purple has 2 x-intercepts. It has 1, 2, 3 turns. So that's not weird, okay? But it means that the degree is not 2. It's got to have a higher degree. The degree's got to be higher than the number of turns. Okay, the end behaviors are both the same direction, so it's definitely an even. And so since there's 3 turns, we're going to go one more than that. Let's say 4th degree. And that's the minimum. It could be higher. The minimum degree, but we're going to learn that is a 4th degree. Again, notice right at this turn, this relative extrema does not go below, so that's why there's not as many x-intercepts. The change of direction happens before the x-intercepts. And then the black function, how many x-intercepts does that have? 1, 2, 3. That's 3 x-intercepts. It has 1, 2 turns. And so this will be a 3rd degree. And again, end behaviors are opposite, so I know it's odd. Okay. We could also identify leading coefficients. Okay, we got to do a little bit more studying on that, an examination, but leading coefficients dictate the right end behaviors. All right, so if the right end behavior is positive infinity, then the leading coefficient will be positive. If the right end behavior is negative infinity, then the leading coefficient will be negative.